Hello and welcome to the Lesson 1 notes. Today we are going to start with some multiplying fractions. So this one's going to be more of a refresher for you guys out there who are already kind of used to multiplying fractions. I will be doing drawings on a screen so that you guys can see them. So the general idea, whenever you are multiplying fractions, is that you want to multiply the numerator by the numerator, so the numerator is the number on top, and the denominator by the denominator, so that's the number on bottom. So we're going to switch over to a little screen over here. Okay, and I'm going to show you guys what I mean by that. So let's say we have 1/2 and we are multiplying it by 2/3. All right, so we're multiplying it by 2/3. Okay, so that would mean that the 1 and the 2 are the numerators in this situation. So in order to get my new numerator, so what it's equal to, I'm going to have to do 1 times 2, which of course is 2. So that will give me the top of my fraction. So, over here I've got the, should separate those out. I've got the 2 right there. Meanwhile, when I say the denominator, I'm of course referring to the numbers on the bottom of the fraction. So that's going to be 2 times 3, and then of course 2 times 3 is 6. And so we are going to talk in a second about equivalent fractions and how to make this a little cleaner. But some of you already probably know that whenever we're multiplying two fractions, so I'll do this one in pink. So let's say we're doing that exact same multiplication. So some of you guys already know that whenever we have a numerator and denominator that match, so right here and right here, so we have a 2 in both the denominator of the first fraction and the numerator of the second fraction. So when things like that happen, you can actually cancel those numbers. And the reason for that is because the numbers on the bottom, we're actually dividing by them. So if we were to write out what this really means in big log chain, so we'd start off with the number 1, and then we are dividing by 2. So the dividing by 2, that's what this number right here is doing. So then we're multiplying by 2 divided by 3. So then, we're multiplying by 2, and then we divide by 3. So one thing that happens right here in the middle is we both divide by 2 and we multiply by 2. Okay, so if we divide by 2 and multiply by 2, we're essentially canceling those two terms out. It's kind of like what happens when we do -2 and +2. So if we did those together, you would go, oh, well, of course I can cross those out. They're exact opposites. The same is true with divide by 2 and times 2. So if you happen to be multiplying fractions and you got the same number across the numerator and the denominator, then you can go ahead and cancel those numbers to make your life a little easier. Because as you can see over here on the right with this little purple example, if we were to do that, we'd just be left with 1 divided by 3, which would give us 1/3, which was, of course, the answer to our problem in a second here. So 2/6, that's going to be the same as 1/3, which is going to be the next thing that we get into. And so let's go ahead and take a peek. By the way, on the right, these videos, they do play, but they don't play while they're in Canvas. So if you want to watch these explanations from Khan Academy, be sure to go ahead and download the presentation, open it, and enable the content. That will allow you to just click it. And
We're
then
asked to multiply
right over
5
here, the gentleman at Khan Academy will be going over the video explanation, just in case you want to go through these yourselves before you see my explanations, or if you just want some extra help on the side, we've got Khan Academy resource videos for that. So now let's talk about simplifying fractions. So simplifying fractions is something we do typically after we've multiplied. Not always. Sometimes we just simplify them if we have them. So let's go ahead and head back to our board. And we're going to erase a little bit because, my goodness, all these colors, the big old mess of colors. We need to calm down and go back to what we had. Okay, so we had 1/2 times 2/3. And that resulted in 2/6. Okay, so this 2/6 can be written in a couple of different ways. So what we're going to do is we're going to look at the numerator and the denominator. We're going to separate them out a little bit. So 2 is the same as 1 times 2. That's, pretty straightforward. Any number times 1 is equal to itself, so that's fine. Meanwhile, on the bottom, we actually have a couple of options. So 6 can be factored into 1 and 6 and 2 and 3. So we are going to go with the 2 and 3 option. Now, the reason we're going to go with the 2 and 3 option is because now we have a 2 on the bottom and a 2 on the top. And as we just discussed, that means that we can actually go ahead and cancel these, meaning that we have, 1 over 3, which is what we discussed before. This is how equivalent fractions can be reduced. So whenever a question wants you to reduce a fraction, you can just, factor it so that you have, same number on top and bottom, and then you can cancel. Now you might be asking, well, what happens if I can't do that? What happens if the numbers I have, they don't factor so that I can divide them like that? And okay, fair enough. I'll give you an example of that right here. So let's say we have 14 over, let's say we have 14 over 15, okay? So 14 can be divided into, so here we do this in red. So we have 1 and 14, and then we have 2 and 7. So we are just going to keep that in mind. We'll pick which ones go on top and bottom here in a moment. But meanwhile, we'll go ahead and do the bottom over here. So if we are divide 15, that gives us 1 and 15. And it also gives us 3 and 5, because 3 times 5 equals 15. Now, as you might have noticed, the only number that is the same for both is this 1. So it's not like over here where here's a 2 and there's a 2 that we can make work. No, this time there's no matching numbers outside of the 1s. Now, if this is the case, then this fraction is already as simplified as it's ever going to be. And the reason why we can go ahead and call that is because, so let's say I put 2 times 7 up here. So 2 times 7 over 3 times 5. Now, unlike before, where, I had these specific numbers that match on top and bottom, now I don't have any of those, so I can't really do anything here. So if there's no matching numbers, there's nothing to cancel, so we just stick with the 14 over 15. So there's nothing to change there. However, and this is something that doesn't always come up, but it is something that you can do, and sometimes it's useful, is the idea of an equivalent fraction that's actually bigger than what we started with bigger numbers. So let's say we go back to 1/3. So a little bit earlier, I said that we could factor any number into 1 times itself. So we can do 2 is the same as 1 times 2, because 1 times 2 is 2. So any number times 1 is just itself. So multiplying by 1 means that there is no change in value. If you multiply by 1, always the same value, nothing to worry about on that front. So that is exactly what we're going to do with this fraction we have here, 1/3, is we are actually going to multiply it by 1. Now you might be thinking to yourself, wait a minute, multiplying by 1, won't that just give us 1/3? That doesn't really change anything. And that's true. If we were to just multiply by 1, which is the same as 1 over 1, then it's not gonna change anything. However, 1 over 1, or the number 1 that you're multiplying by, can be written in a lot of different ways. So 1 divided by 1 is 1. So if we took 1 divided by 1, we'd get 1. Now, it's also true, however, that 2 divided by 2 is also 1. So, if you have two groups, if you have two objects, so let's say we have 2 circles, and we want to make groups of 2, well, there we go. We've got a single group of 2, and both of these objects are inside of it. So 2 over 2 is also 1, which means we can change this from times 1 to times 2 over 2, and that would be exactly the same, because 1 over 1 is the same as 2 over 2. So now, if we were to write that 1/3, so it's still 1/3 at the end of the day because we're only multiplying by 1, but now 1 times 2 is 2, and 3 times 2 is 6. And we know that this is equivalent because, as we showed before, 2 is the same as 1 times 2, and 6 is the same as 2 times 3, which means that if we were to go ahead and cancel out those 2's, then we would just wind up with 1/3, which is the same as what we started with all the way back in the beginning. So if you need to make a fraction larger, or, the numerator or the denominator, then go ahead and multiply by, whatever number you need to multiply over itself. That makes it so that you can make your denominator and numerator pretty much anything you want. As long as you don't break the rules of algebra, when you multiply, make sure you multiply correctly, and you'll be good. And then if you need to make it smaller, you just do what we talked about before, where you factor the top, factor the bottom, and you'll get your equivalent fractions. Okay, so now we're going to cut back over to the presentation. Okay, and of course, again, the video is here. If you need it, you can click it and it'll start playing, and you'll be able to watch it as long as you have it on your computer. While it's in Canvas, it won't be able to play it. I'm sorry that doesn't work that way. It's just weird like that. So next up, we are going to look at dividing fractions. Okay, so dividing fractions, now you might think to yourself, wait a minute, dividing fractions, aren't fractions already division? And the answer to that question is yes. Yes, they are division. So as you might expect, dividing with fractions, it could be a little bit weird. So what we're going to do is we're going to do our best to make that process a little less weird. So let's talk about multiplying and dividing for a second here. So let's say I have, oh, wait, that's not my brush, sorry. So let's say we have 2 times 2. Okay, so this is pretty straightforward. 2 times 2 is 4 because you have 2 rows with 2 in each of them, so you've got 4 dots total. Very straightforward, very simple. So now, say we have 2 divided by 2. Okay, well, 2 divided by 2 is 1. We kind of discussed that earlier, but the reason is because, okay, so we got 2 dots, and we're making a group out of 2 dots per group. So that means we've got 1 group total. So that's fair. That's fair enough. That's nice and simple. So now, let's talk about 2 times 1/2. And it's like, oh, okay. Well, this is a little different. But we talked about this a little bit. So 2 can be written as 2 over 1. And, of course, the 1/2 is the 1/2. So, hey, that thing we mentioned earlier, so the 2's can cancel because, there's 1 on top, 1 on bottom, meaning we got 1 over 1, which is just 1. So, hey, wait a second, this one and that one are exactly the same. So multiplying by 1/2 and dividing by 2 are always going to give us the same answer. And that is not by accident. That's actually on purpose. So the way division works is we start off with some multiplication. So, 1 times 2, that's 2. Okay, good, excellent. I think we can all agree, very straightforward. We like that one. So, but here's the thing. So that also means that we can do some division, division to make stuff happen. So let's say I divide this whole thing by 2 because, the rules of algebra say you can do whatever you want as long as you divide both sides, right? Or as long as you do it to the other side. So we've got 1 times 2 equals 2. And so what we're going to do is we're going to divide everything by 2. Okay, so 1 divided by 2, that would be 1/2, because it's just 1 over 2. Because fractions are just division. So 1 is the number that we are dividing. 2 is the number that we are dividing by. Numerator, denominator, respectively. All that good stuff. So we've got 1/2 times, okay, so 2 divided by 2 is 1. We talked about that earlier. And of course, 2 divided by 2 would be 1. Now you'll notice that does not work because whenever you're multiplying, you do not distribute to both terms. If they're just being multiplied, you have to pick one or the other. You don't do both. And that's not super important right this minute, but it is something to keep in mind whenever we go into like variables and stuff. But for right now, know that, okay, so we just divided by 2 with the 1. So the other one gets to stay a 2. So half of 2 is 1. Makes sense. So that means, since, we're always going to get the same result. So, 2 divided by 2 is the same as 2 times 1/2, that means that there's a relationship between divide by 2 and times 2. So I'm going to clear the board real fast, and we're going to talk about what that relationship looks like. Okay. So let's say we've got some number, let's say 6, and we are dividing 6 by 2. So that will give us some value. So here's the thing. 2 is the same as 2 over 1. Any whole number can be written as itself over 1, which means that when we go to do the times 1/2, all we're really doing here is we're taking this part, we're turning the division into multiplication, and we are flipping the fraction upside down. So that means that whenever we're dividing by a number, we're actually multiplying by the fraction flipped upside down. And the whole flipped upside down thing has a word, it's called reciprocal. Yeah, sorry, my spelling's not the best, but this is how you spell reciprocal. So reciprocal just means you take a fraction and you flip it upside down. So with whole numbers, we usually don't have to worry about that. We can just write it as a fraction. It's just a neat thing that happens. But there are some situations where we're not that lucky. We have to do something a little crazier. So let's say we have 1/2 and we are dividing it by 2/3. Now, technically speaking, we can try to logic our way through this, try to imagine, a half that gets split into groups of 2/3, but I don't know about you, but that doesn't really easily come to mind. Not in the same way that 6 divided by 2 would, or 2 divided by 2 would. This is a very different kind of picture. So now that the picture is much harder to rely on mentally, we're going to use that trick that we saw before. So we know that divide by just means multiply by the reciprocal. So we're going to flip that second fraction upside down. So that'd be 3 over 2. And now this is much easier to do. Much easier. So 1 times 3 is 3. 2 times 2 is 4. And just like that, we've got the answer in a nice, neat, easy fashion. It's much easier than trying to do all of this junk. So then we'd have 1 over 2. So this would be if we'd actually tried to do it in our heads. So we'd have 1/2 over 2/3. And it looks like that. Yeah, that's a big mess. I'm good. I would not recommend doing it this way. You can if you want to. But basically what you're going to wind up with is you're going to come right back to here, and then you're going to wind up doing the multiply by the reciprocal. It's just the way fraction division works. So anytime you need to divide a fraction, just multiply by the reciprocal. So take the second guy, the guy after the division sign, flip him upside down, then multiply as you would normally, and now you know how to divide fractions in case you ever need to. It doesn't always come up, but in those cases where it does come up, you really want to make sure you know your business. So we're going to cut back over here. Now we're going to talk about adding and subtracting fractions. Okay, so adding and subtracting fractions is where we start to pick up some more rules. So there are 2 ways we can add and subtract fractions. One of them is very straightforward, and one of them is a lot more difficult. We have to do a lot more legwork. So let's start with the easy one. When we add fractions whose denominators are the same. So let's say I have 1/3 plus 7/3. Now you'll notice that here the denominators are exactly the same. So whenever we are adding fractions with the same denominators, we never change the denominator. We never change the denominator. And I will spell denominator correctly. Denominator. So that's if they are the same. If the denominators are the same, we're just going to keep them. So that means that if it was 3 before for both of them, it's going to be 3 at the end for both of them. So whenever you're adding or subtracting fractions, make sure your denominators line up. And now you might be wondering, well, what do I do if the denominators are different? What do I do then? Don't worry. That's the harder one. We'll do that one in a second. So for right now, if the denominators are the same, then you just keep the denominator the same across the addition. Now, across the top, I will make sure to do that same color that I've been doing up to this point. So across the top, you actually just add those numbers. So, 1 plus 7, that would be 8, which means that for the top, 8 is our denominator. So, whenever you're adding fractions, if the denominators are the same, then just keep them the same and do whatever operation the top needs. So if it's, 1/3 plus 1/7, then do 1 plus 7 on top, leave the bottom as 3. And now you might be wondering yourself, well, wait a sec, that's weird, because with when we were multiplying and dividing fractions, they got different. Well, why did those change but these don't? And I will show you, because I know a lot of students have that question. So let's say we have 1/2 times 2/3, and over here we'll have 1/3 plus 2/3. Actually, you know what? Let's make it fourths. Say 1/4 plus 2/4. So we can see how this goes. Okay, so over here on the left, we are starting off with 1/3. So this guy right here are starting off with 1/2. So we start off with this guy, and he looks like this, and it's 1/2, and so the other 1/2 would look like this. Fair? Okay. So now we look at this guy over here. This guy over here says 2/3. So that means whatever we started with, we're going to cut it into 3 pieces, because that's what this 3 means, is you cut it into 3 pieces, and we're keeping 2 of those pieces, because that's what the top means. So up here, we're going to cut this into 3 equal pieces, and I'm going to cut through to the other side so that you can see what that looks like. Okay. So now, I'm only keeping 2 of those, so I'll mark the ones I keep. So I keep this one, and I keep this one. So these are the ones that I'm keeping. That last one is left out. We don't get it. So with the way this process works, the pieces are now fundamentally different sizes. So now, instead of having one big piece that represents a 1/2, I now have smaller pieces that are about a 1/6. I would need 6 of these pieces in order to make one whole number, which means that my final answer now has to be in 6, because that is the number of pieces I would need to make a whole. There are 6 of these pieces now, and we have 2 of them. So we have 2 pieces that we would need 6 of in order to make one. So we have 2/6. So the sizes of these pieces have fundamentally changed. That's what happens when you multiply by a fraction. Meanwhile, over here on the right, we have fourths and fourths. So all these pieces are going to be the same size. So over here, so I've got 1/4. And then over here, I have 2/4, which you could say is a 1/2. But notice how all these pieces are the same size. There's no changing any of them when I'm adding them. Because when I add, I just count up how many there are. So I have 1/4 on the left and 2/4 on the right. The plus sign means that I need to add these guys. So if I add them together, I will have I now have 3 pieces, all of which have a 1/4 in size. So 4 of these pieces would make 1, and all I've done is move them together so that they're all in one place. So that means my final answer for this guy has to be all 3 of these pieces accounted for. So I get to have all of these pieces when I'm making my answer, which means now I have 3 pieces, all of them are a 1/4 in size. So I've got 3 pieces of 4. If I had another, I could make 1. Whereas over here, I've got 2 pieces of 6. I would need another 4 pieces in order to make 1. So over here, I started with 1/2. I ended with a 1/6 because multiplication changes the size of your pieces. Whereas over here, I started with 4ths and I ended with 4ths because addition doesn't really change how big the pieces are. It just tells you how many pieces you have to work with. And of course, this is the easier version where, you know, all of the pieces are the same size, but, you know, it's not always the case that all the pieces are the same size. And now we're going to go ahead and switch back to the presentation and talk for a second about where that comes in. So those would be the harder questions. If the denominators are not the same, what do I do? What if they're different? And then how am I supposed to take care of that? You told me if they were the same, I was never supposed to change them, and that is absolutely correct. So now let's talk about what happens when they are different, because when they are different, we have to do a little bit more work, but we can still make it happen. So over here, let's say I have the fraction, well, let's say I have something to write with. So let's say I have the fraction 2 over 4, and I'm adding 1 over 7. So now these pieces are totally different sizes. They're not even close to the same. Fourths and sevenths, oh my goodness, they're so different. But remember before how I said you can always multiply by 1 and it won't change the value? Well, I wasn't kidding about that. So what we're going to do is we're going to multiply both of these fractions by 1, but we're going to do so in a way that makes them fit together. So over here, I start off with 1/7, and I'm going to multiply by 1, but I'm not going to multiply by just any 1. I'm going to multiply by 4 over 4. Now, the reason for this is because I want the fourths and the sevenths to match up. But in order to do that, I'm going to need to multiply both of these terms. I'm going to have to multiply the 4 by 7 over the 2 fourths by 7 over 7, and I'm going to have to multiply the 1/7 by 4 over 4. Because if I do that, I will get 4 28ths, because 7 times 4 is 28. On this side, and over here, I'm going to multiply by 7 over 7. So, and I originally started with 2 over 4. So if I multiply that guy over there, that's going to give me 14 over 28. And you might have noticed that, yes, you can reduce this fraction and this fraction, but we don't want to do that right now. We don't want to do that right this second. Right this second, we want to do 14 over 28 plus 4 over 28. Because now guess what? Our denominators are the same. Yay! That was what we wanted all along. That's why we did this. So now that our denominators are the same, we can do what we just did a minute ago. You know, that same thing. So the 28 is still on bottom. And now I just add the top. So 14 plus 4 is going to be 18. And now, if you wanted to simplify this, you could very easily. So 18 is 2 times 9. And 28 is 2 times 14. So, you know, we're just going to cancel those 2's. And we're left with 9 over 14 as our final answer. Now, you might have noticed that this addition requires a lot more work. It requires you to think a lot more. It's like, oh my goodness, the fourths and sevenths, how do those go together? And it's like, well, so basically, the shortcut is that whatever number's on bottom over on the other fraction, you multiply by that number over itself on the other side. So you keep the values the same, but you multiply by the other guy as 1 over 1. And I'll do one more to kind of go through this one more time, because I'm sure if you didn't like this the first time, you might want another example to work with, which is totally okay. That's totally fine. Nothing wrong with that. So real quick, so let's say we have 1/3 minus 1/2. Oh my goodness. So now we got to do this. So over here on the left, so we're going to multiply top and bottom by 2, because we got the 2 right there. And we're going to multiply the other side by 3 on the top and bottom, because we have a 3 over here. So on the left-hand side, after I simplify everything, I'm going to have 2 over 6, or simplify was the wrong word. I meant multiply. As soon as I multiply everything, so I have 2/6 minus, over here on the right, I've got 3/6. And now all I have to do is subtract, because the bottoms are both 6, so I'll just keep that 6 right there. And then I do 2 minus 3. 2 minus 3 is -1. So -1/6 is my answer. And there we go. That is the fraction stuff for today. I am going to leave this here. So, oh, hold on. Sorry, I didn't switch the camera over. My bad. Okay, so this is the previous one. So, of course, we're finished with this stuff. So, I'm going to go ahead and leave this part up here. So, this is like a little bitty challenge thing that I'm going to go over whenever we do the in-person hours. But I'm going to leave this challenge up to you guys so that you can try to attempt it on your own and see if you know how to do it. So this question is asking pretty basically, if you need to make 3 loaves of banana bread, how much of each ingredient do you need? Now, you might notice there are a couple mixed numbers on here, and if that's tripping you up, that's okay. I'll give you a little hint, a little helper right now. So right here we have 2 2/3 cup flour. So let's go over real quick. So 2 is a whole number, right? Okay, so 2 is a whole number. So we have 2 2/3. So this is the same as 2 plus 2/3. And now we can make 2 into 2/1. And now that process that we just discussed, the whole thing about, changing the denominator so you can add them together or subtract them. Now you can do that with the mixed numbers you have over there. So if you want to do 2 2/3, you make it 2 plus 2/3, and then you do that process that we were just talking about a second ago. But I will go ahead and leave this up here for you guys to try out without me. And then, of course, I will be online so that you can try it with me whenever we go to do the synchronous hours. So I'm going to leave that. That's the fraction stuff. And in the next video, I'm going to be tackling the next topic in this. I believe it's exponents. Yeah, it's going to be exponents. So in the next video, I'll go over exponents. See you then.